Hey everybody, today we'll be doing the hands-on part of the series circuit, and this is how the series circuit looks. I pre-made this little quickie because it's going to take some time, and it's this, it's very basic anyway. I think you can follow it through. Here is the voltage source. It's going to be the negative lead from the power source, and this is going. The positive lead and the negative lead. Right. Then here, as you can see, R1 is connected to the positive. Right? So this is this from the positive bus here is coming a jump to R1, right? And then R1, right? This is R1, and then R2 is connected in series with R1, and R3 is connected in series with R2, and R4 is connected in series to ground. This is connected in series to ground. You can see this black wire going across here, and it's connected to this green wire jumper coming from the negative side of the power source. So you can actually see that that's what we have. That's what we have in the when we did the theoretical calculations, and that's what we have. That's the values that we have here. I total was 1.59 milliamps or 1.58. It doesn't really matter. I think that we say that was 1.58. So because what happened is that these values were 1.58 milliamps, right? 1.58 milliamps. And what happened was the first video that I did, I rounded up to 1.59. But what happened, that video I could not upload it in YouTube because the file got corrupted somehow. So, but anyway, those are the values. I total is 1.58 milliamps, and BR1 is 5.24 volts, and VR2, R3, and R4, all of them are 1.59 volts, right? Okay, so we got that, and as we know that the circuit in this breadboard, it looks like exactly the same circuit in the paper. You can see that, and here you go. All right. Okay, so now let's apply some power to the circuit, right? Okay, but before that, let me just measure the resistance. And to measure the resistance, like I said last time, you make sure that the resistance that the circuit is dead. You don't want to make measure resistance with power on, right? Okay, so let's do this. And this is the challenging part because I don't know if the camera is actually looking at this properly. So So here, if I actually here you go. Yep. 6.28. 6.28 kilo ohms, right? That's very close. That is very, very close. That is very close. Yep, 6.28. 6.28. 6.28 kilo ohms, right? So 6.28 kilo ohms. That is the resistance. Now, let's measure the voltage. Why not? All right, so let's apply some power to it. And let me change the meter to 10 volt DC. And let me just put the positive lead in the red one, and the negative lead in the green. And making sure they're not touching each other, because sometimes these alligator clips can move and they can touch each other, and then the power supply start going crazy. Okay, so now that we have the let me see if I can actually see right there. So now if we actually do BR1, if we do BR1, we can see that it's 5.25 volt. That is exactly what we got. 5.24, 5.25, and I am good with it. I am good with it. 5.25 is fine. Now we said that R1, that R2, that was the voltage in R1, right? And that is what we have here, right? That's what we got there, right? Actually, it's 5.24, but it's fine. I mean, it's fine. 5.24 or 5.25 is good enough. It is good enough. Now we say that the voltage on R2 was 1.58 or 1.59, right? So 1.58, I can go with that. Yeah. For 1.59 volt. That is R2, and R3 is going to be 1.59 again, and then here is 1.59 again, 1.58, right? So R2, R3, and R4 is 1.59, 1.58, which is fine. I mean, right, I can go with that, no problem, right? Now, if we take from this point to if we take from this point from this resistor to this resistor here, it's 10 volt. See that? It's 10 volt. And that is the sum of the voltages. See? 1002, remember when we did the calculation was about that? Yeah. Yeah, 1003. And it's good enough. Good enough. See, that is the sum of the voltages. Because I am measuring, technically I am measuring here. It's like I am putting the leaves right there, right? Right there, right? So that's exactly what I'm doing right now. So yeah, so we found the voltage. Now we need to just quick do the current. We need to find the current. So when I find the current, I am going to take this resistor R4, I'm going to pull it out. I'm going to pull that out. R4, I'm going to pull that out, right? And I'm going to put a piece of wire right there in that same column, right? Put the resistor, okay? And pull it out. Then I take a piece of wire and put it right there in that column. See? Now I got a piece of wire here, so I'm going to measure current from here to this resistor. From this piece of wire coming connected to ground to the positive side, that is that resistor. So I need to actually measure the current coming through that resistor, or actually coming across the whole system. That is I'm sorry. The current coming through the whole circuit, I am going to measure right there at that point, right? So so that's the positive, that's the negative, and actually I need to change my meter to 20 milliamps. I'm going to change it to 20 milliamps, right? So let's do that, and here you go. 1.57, 1.58, 1.58. 1.58. So we had a 1.58 or 1.59. We say that either those numbers was good. All right, so we had the current 1.58 in the current, and that is exactly what we have here, 1.58 milliamps. Okay, so that is the basic analysis for this basic series circuit, and that's how you measure voltage and current in a simple series circuit. I hope you learned something out of this video, and thank you for watching.